This is the Circles Rotation EOC review. So we're going to start out by going through this circle and talking about what a variety of things are. Obviously, I think most of y'all know what the center of the circle is. It's A. Interior of the circle is the inside, and in my picture it's gray. Exterior of the circle is the outside, and that's white here. And I just put an arrow towards these because on y'all's paper you don't have the gray. A radius is a segment that goes from the center of the circle to the circle. We have 3 of these in the drawing, but I want to know the one that is just a radius, and that one is AJ here. If you notice from A to J here. The other 2 are AE and AD, but those are also something else. So next we're going to talk about a diameter, and a diameter is a chord. A chord is a segment whose endpoints are on the circle. The difference is a diameter is a chord that goes through the center of the circle. So that's ED right here, ED, this segment right here. And it has a segment symbol over top of it again, which is a line without arrows. We have 3 chords in this drawing, and a chord, again, I just said what it was. It's a segment whose endpoints are on the circle. So we have ED, that is the diameter, but again, I want to know the one that's just a chord. We have another one over here, KC, that with a segment symbol over it could be the chord, but the one that is a chord only is right here. It's BG, and that's the one we're going to refer to. Now, a tangent is a line that intersects the circle at one point. We have one line here, FH, that intersects the circle at one point. And again, we have to put that line symbol over the top of it. The point of tangency is up here at H. Now, a secant is again a line that intersects the circle at 2 points. Now, we have our line right here that intersects the circle at K and at C. Now, we could name this FC, or we could name it KC. Doesn't really matter which one we name it, but remember again, it's a line, so we have the line segment over or the line symbol over top of it. And then we need to talk about what is the outside segment of the secant. So here's our secant again, FC. So the outside segment of that segment is FK, and again, it's a segment. And then the inside segment is right here, KC. And again, it's a segment. So now we're going to use some of these terms as we talk through some of these problems. So I want to make sure y'all were familiar with the terms. So on this next problem, it says tangent and radius are perpendicular and form a right angle. So line L right here is our tangent, and AB is our radius. When we have a tangent and a radius, they always are perpendicular, which means they form a right angle. So we can put a right angle symbol here. Now, also, oftentimes when you see problems like this, they're going to have an additional line here, like AC. So I told my students to go ahead and draw that. Now, if you look at this now, you should see that there's a right triangle there. And when we have right triangles, we use Pythagorean's theorem to solve them. So oftentimes, again, if there's a problem like this and you're trying to determine if the angle at B is a right angle, which is what proves that this line L is a tangent, then we're going to use Pythagorean's theorem to do that. So this next one is a tangent AB here. We know again that AB and AC are tangents because they intersect the circle at the same point, at one point. These tangents come from the same point, so we can say that these 2 tangents are congruent. So let's look at a problem where we use that. So if you look on your worksheet, you will find that number 1 has 2 tangents, and the formula we're going to use to solve number 1 is tangent equals tangent. So when you do this problem, again, we should see that this and this are congruent. The next concept, if chords are equidistant from the center, chords are congruent. If chords are congruent, they are equidistant from the center. That term equidistant means the same distance. So we know that PM here, right here, and PL are congruent because they have tick marks on them. We can also see that PM is perpendicular to BC, and that PL is perpendicular to AD. So if all of that is true, then we can say that chord BC is congruent with chord AD. Chord BC is congruent with chord AD. So I'm going to go ahead and put some tick marks up here that indicate that. Now the one over here on the right is just the converse of that. This time we can see that chord CD and AB are congruent. And we can also see that CD is perpendicular to, perpendicular to OF, and we can see that AB is perpendicular to OE. That means then that these segments OF and OE are congruent. So again, I'm going to put some tick marks on this that indicate that. Again, these are rules that we could be using on questions that are on the EOC. Our next concept is we have two chords that intersect inside a circle. So when we have two chords that intersect inside a circle, we're going to multiply the part of a chord times its other part, and we're going to set that equal to, again, part times part. So again, if you look at your worksheet and find the problem that looks like this one, it's number 4. And the real key here with this, with circles information is we need to be able to know what formula to use with what problem or what question and what image. So on this one, again, we're going to have part times part equals part times part. So go ahead and write that down next to number 4. Our next concept, if a radius or diameter is perpendicular to a chord, then it bisects it. So here again, we have CD here, which is a radius, and we know that it's perpendicular to EF because there's a right angle symbol there. So that means that we know that CD bisects EF, resulting in 2 congruent segments. The same is true if it's a diameter. Now, again, with this problem, we're often going to see another segment drawn. So we're going to see a segment like CF, and you should immediately notice again that we now have a right triangle. Well, if we have that right triangle, then we know that we can use Pythagorean's theorem again. Now go ahead and look for a problem that looks like this on your worksheet. Hopefully you found it, number 5. So when we do this problem, we are going to have an A, a B, and a C again, because we have A squared plus B squared equals C squared. So the one that we need to really notice is that X is going to be our C because it's opposite the right angle. Now, the other question that could arise with an image like this is, what is this length right here? So if that's the question, then again, we know that these 2 segments right here are congruent because we have a radius that is perpendicular to a chord, which means it bisects the chord. So if we were looking for that question mark, it would be 8.2. So then we have the segment of secants theorem. So here we have two secants, that are intersecting with a circle, and they meet outside the circle. So when we do this problem, we're going to do outside times whole equals outside times whole. So our outside is here, MN, and our whole is MO. This one is MP, and again, the whole is MQ. So I'm going to put some numbers up here because I think you'll understand it better if I do it this way. So when we do this, we're going to do 4 times 4 plus 5. And then we're going to do X times X plus 6. That's how we're going to set this up. So this is going to end up being 4 times 9, and X times, and this is X plus X, so that's 2X plus 6. 4 times 9 is 36, and we get 2X squared plus 6X. Now, this is one of those problems where we're going to have to move this 36 to the right. We're going to get negative 36. Now, our next step is going to be to factor this. So now, when we're looking for solutions here, if we get a negative number or if we have any negative answers, we can eliminate them immediately. Because we're solving for X over here, there's no way that that value could be negative because it can't have a negative length. So we know that we can eliminate any negative answers. Now, let me also tell you from a testing strategy standpoint that if you don't remember how to factor or you're having difficulty with factoring, then what you need to do is plug your answers back in. So let's say that we had an answer that was 3. So if 3 was the answer, then we could put 3 in here and 3 plus 6 here. And what we're going to do is we're going to compare this to what we got at the top. So 4 times 4 times 4 times 9, that was 36. So down here, we're going to have 3 times 3 plus 3, which is 6, plus another 6, which is 12. So 3 times 6 is 36. So that's our answer. So again, if all else fails, plug the given answers back in there and see which one makes the problem true. Again, that's a testing strategy. So here's our problem that maps to that one. Outside times whole equals outside times whole. So 9 times 16 equals 8 times 8 plus X. This other one is our segment of secants and tangents theorem. So UV is a tangent, and y is a secant. So here again, we're going to square our tangent and we're going to set that equal to our outside times our whole. If you look on your worksheet, this is question number 2. So on this one, here's our tangent, 18. So again, write this formula next to that problem. But you're going to do 18 squared equals 12 times 12 plus x. That's how you set up the problem. Now, an equation of a circle. Now, I want to point out to you that this formula is on the formula sheet. However, it does not tell you that h and k in that formula equals the center and the r is the radius. Now, if you don't know that r is the radius, I don't know what to say. So here's the deal. So it says find the equation of a circle when given the center and the radius. So if that's the case, all we have to do is plug in h, k, and r. Now, if you look, that is like this question right here. We have the center and we have the radius. So all we have to do is plug those into the equation. X minus h squared plus y minus k squared equals r squared. So all we have to do there is plug those into that formula. All right, now the next one here says find the equation of a circle when given the center and a point on the circle. So when we do this, we have to solve for r because we don't have r. So we're going to plug in h, k, x, and y. We're going to solve for the r, and then we're going to put the h, k, and the r back in to find the equation, just like we did with the first question. So this is like number 7. So here again, we're going to use our equation, x minus h squared plus y minus k squared equals r squared. The difference is we're going to plug in the x, the h, the y, the k, and we're going to solve for r. Then we're going to plug the h and the k back in along with the r to get the equation for the circle. Now our third option here of seeing a problem like this would be to determine if a point is on a circle. Now this would be one where you're given the equation for a circle, and then they ask you, does this point lie on the circle? For this problem, all you have to do is plug in the x and y into the equation of the circle and see if the result is a true statement. If it is a true statement, the point is on the circle. So what I mean by this is if you get a statement like this, 16 equals 16, then yes, that point was on the circle. If you get a statement like 12 equals 16, that's not a true statement. So that point would not be on the circle. All right, now we're going to flip over your page and we're going to go to completing the square. Now, I think most teachers told you guys that we need to group the x's and the y's in the parentheses. So we're going to do that first. X squared minus 10x, and I'm going to create a blank over here for a number that we're going to fill in up there. Same with the y's, y squared plus 8y plus blank, and we're going to move that 16 to the other side, and the way that we do that is we subtract it. Now down here at the bottom, I'm going to go ahead and put an x in my first set of parentheses and a y in my second set of parentheses, because that's the way equations for circles look. Now what we need to do is we need to divide our middle term, the coefficient, by 2. So we're going to divide negative 10 by 2, and we're going to put that number down here. Negative 10 divided by 2 is negative 5. And 8 divided by 2 is 4. Now our next step is going to be to just square that number and stick it back up there in that blank. So we're going to square negative 5. That gives us 25. Now remember, anything that we add to the left of the equal sign, we have to add to the right. Also, we're going to square the 4 down here. And so that's going to give us 16. And so, again, we have to add the 16 over here. Now, you'll notice the 16 and the negative 16 cancel each other out, so we get 25 down here. Now, if you'll go back and look at our formula, again, it's x minus h plus y squared plus y minus k squared equals r squared. So what we have to notice when we look at this formula is that there's minuses in the formula. And what that means is that when we pull the number from the equation, we're going to change the sign. So when we're talking about our center, we're going to talk about changing the sign of the negative 5. So that's going to be a positive 5. And changing the sign of the positive 4. So that's going to be a negative 4. Now, the formula has r squared. So that means if we're trying to find r, we have to take the square root of r squared to get r. So that's exactly what we're going to do. Now, I want you guys to notice that 5, negative 4 has the opposite symbols from negative 5 and positive 4. So if you are not going to remember this, you need to make yourself a note. so that you can go back and study this. And remember that you're always going to change the signs when you pull those numbers, because I can guarantee you that one of the answers for the center will be negative 5, 4. So you have to remember that you're going to change the signs of those numbers. And this problem, number 8, is the one that is like what we just did. Now, I would start this problem by moving all the terms to the left side of the equal sign first, so then it looks like what we just did, and then proceed through the process after that. All right, now, let's talk about, sorry, I'm making a mess here. Let's talk about central angles. Now, central angles, vertices, are at the center of the circle, like this angle is. Now, when we have a central angle, it is equal to the arc. So if that angle is 60, then our arc here, AC, is 60. So if angle ABC is 60, then arc AC is 60. Now, if we were to, and this is a minor arc because it's the shortest distance between the 2 points. This is arc right here, AC, if you notice that, okay? So down here, we're talking about this major arc here. Now, if we said again that this was 60, then the way that we would find that major arc is to do 360 minus 60, which is 300 degrees. So that's what this major arc would be. Now, down here at the bottom, we have a semicircle, and we should all know that the measure of a semicircle is 180 degrees. Now, I want you to look for the problem in your problem set, and see which one we're going to use these properties with. So it's number 9. So on number 9, you need to remember these 3 things. Central angles equal arcs. Vertical angles are congruent in that a semicircle is 180. So I want to show y'all something here. So if I draw this and this, we're talking about this angle right here. This is the angle they're asking us to find. Now, I noticed by drawing those 2 diameters that this angle right here is a vertical angle. So to find the angle over here, all I have to do is add these 2 together, 46 and 67, which means that the angle on the opposite side, FKJ, is going to be the same measure. Now, I have a question for y'all. What if this is what we were trying to find? How would we find that? Hopefully, all of y'all can see that arc JIHG, I did that on purpose, is a semicircle. So I could add again 46 together with 67 and subtract that from 180 to get our question mark. Again, those are the ways these types of problems might appear to you. All right, so now on this one, central angle equals an arc equals a chord. So here we have that the angles are congruent. That means the chords and the arcs are congruent. Over here we have that the chords are congruent, so that means that the arcs and the angles are congruent. Down here, we have that the arcs are congruent. That would mean that the chords and the angles right here would be congruent. So let's look at how this might appear in an actual problem. So on this problem, we have, it asks us to find the length of segment BC. So it tells us down here that BC, arc BC, is 117 degrees. Well, I see that arc BC maps to that chord. Now, I also noticed over here that we're given that CE, that's the segment over here, is 73, and that DC, that's this part right here, is 44. Now, I see that I have this whole red arc here, and it maps to this segment. So, I want to see if there's any comparison between this blue arc and BC, and the red arc, DE, and segment, or chord, actually, DE. So let's go ahead and add these 2 numbers together, 44 and 73. That gives me 117. Well, now what I see is that I've got an arc of 117 right here, and I've got an arc of 117 right here. Whoops, sorry about that. Totally messed that up. There's our other arc of 117. So if the arcs are congruent, that means the chords are congruent. Well, this tells me that DE is 12, and if DE is 12, and our arcs are congruent, then I know that BC is also 12. This is a pretty typical problem like you would see on the EOC. And I got this from an old EOC. All right, so this arc addition postulate. So this means if I add arc AB to BC, I get arc AC. This one, sector of a circle. Now this is again another formula. It is on the formula sheet. The difference is it has this theta symbol. Well, theta means angle measure. So it's the angle measure that we're given in a problem. This question, or this formula, maps to question number 18. So on this one, we've got pi r, the radius is 3, theta, 60, the 60-degree angle, over 360. Now notice down here too that all these answers have pi in them. So I'm not going to multiply by pi. I'm going to leave pi in my answer. So be careful about that when you all take the test. So arc length, this one's arc length. So again, we're trying to find the actual measurement from A to B. So this one again has theta in the formula. So that theta again means angle measure. And the problem on your problem set that maps to this one is number 19. So again, this time we have 2 pi r, and r again is 13, theta, which is 45 over 360. Notice again that all of these answers have pi in them. So we're not going to use this. We're not going to multiply by this pi. We're going to leave it for the end, and our answer is going to have pi in it. So now this is the area of a segment. Now the area of a segment, to do this, we're just looking for this little slice outside here. So we're going to find the area of this sector, and we're going to subtract from it the area of a triangle. So the area of a sector, so we're going to do a problem down here. So go ahead and draw this problem on your paper. This is the formula pi r squared theta over 360. And we're going to subtract from it base times height divided by 2, because those are the formulas for the area of a sector in the area of a triangle. So now we're going to pull the values from this. Now the first thing I want to do is say that this is 10 right here, because all radii in a circle are the same. And I also kind of want to draw for y'all a right triangle, the right triangle that's in here. So the right triangle that's in here, this is 10 and this is 10. That means our base and our height are 10 in that triangle. So when I pull it, pull the values for it, for this formula, our base and our height are 10 times 10. So when we populate our formula, we're going to get pi times 10 squared times 90 divided by 360. Now this time you are going to actually multiply by pi in your calculator, because you're going to have to subtract the area of that triangle from it. So this is going to be about 75, because this is 100. 90 over 360 is 1/4. 100 divided by 4 is 25. 25 times 3 is 75. 75 minus 50, which is what this would end up being, is 25. Now, I need you guys to look at answers when you're doing these problems, because obviously if I get an answer that's greater than 75, then this answer has got to be wrong. So look at your answers when you're making choices and make sure that the answer choice is logical. That's really important. All right, so when we talk about an inscribed angle, the difference about these angles is that their vertex is on the circle for all three of these. So let's just talk about some examples. So if I told you that this angle right here was, let's say 40, then I would know that this arc out here, so if this was 40, then this arc out here is 80. Now if I told you this arc right here was 50, then you could tell me this angle is 25. Again, see the ratio, 1 to 2. Or if I told you all this one was 30, then that angle is 15. So go ahead and look at your problems and let's see if you can figure out which ones have inscribed angles, where the arc is twice the angle's half the arc. So these are 10 and 11. So here again, we're going to find this first, which would be 2 times 86, which would be 172. We're going to subtract 72 plus 86 from 360, because the whole circle is 360 degrees. I want to point something out over here. So this right here is another inscribed angle, if you notice, and this is the arc that it maps to. So to find that arc, we're going to multiply 84 times 2. That's 168. To find our question mark, we would subtract 70 from that 168. Now, number 16 is also a problem that uses this property. This time we're looking for the angle. Well, the angle is half the arc. So the arc's 1/10, so we just divide that by 2, which means it's 55. All right, so this is a problem on your paper that is in black and white, which means it's a little bit harder to differentiate things. So I want you guys to notice that we've got this angle here, ACB, and it maps to this arc AB. Then we have DCB, sorry about that, and it maps to the same arc. And then we also have AEB that maps to the same arc. All of those map to that arc right there. And because they all map to that arc, we can say that those angles are congruent. Now, this might be a little bit confusing to y'all, but when you see it on a test, you need to just literally see if those angles all go to the same arc. We call it the arc is subtending the angle. If the arc subtends the same angles, then those angles are congruent. This one says if a side of an inscribed triangle is a diameter, the triangle is a right triangle. So on this one, we notice again that this arc right here is 180 degrees. And that means that this inscribed angle has to be half of that. So it's going to be 90. So just remember that if we have an inscribed triangle and one of its sides is a diameter, then it is a right triangle actually. So this one says, given that EF is the diameter of the circle, find the measure of EGF. So if this is a diameter right here, then that angle right there has to be 90 degrees. The next one, an inscribed quadrilateral's opposite angles are supplementary. So A plus C has to equal 180 and B plus D has to equal 180. So if you recall on our test that we took on this unit, we added X plus Z, and that has to be set equal to 180. And then we added Y plus W plus Y, and that had to be equal to 180. This is a problem directly from a test that we took in the past. Then we have this rule, tangent and a chord. So when we have a tangent and a chord, first of all, what does a line measure? A line measures 180 degrees, so that means this line down here measures 180. We also know that the circle is 360. Well, that line is half the circle. So that is a relationship that we're going to use when we talk through this problem. So if you notice here, we have this angle right here. And I'm going to give it a measure, 120 degrees, because again, I think y'all do better with numbers. So if that angle is 120, then the arc that corresponds to it has to be 2 times 120. Well, that's 240 degrees. Now, how could we find angle 1? Well, that line measures 180, so can't we subtract 120 from 180? And that means this angle is 60. Well, if that angle is 60, then its corresponding arc is 2 times 60, which would be 120. See if you can find this problem in your problem set, or one that looks like it. So here again, this is our problem, number 13. Our angle is half the arc, or our arc is 2 times the angle. So we could do this 2 ways. We could find out, well, now we're looking for this arc over here. So we know again that this is a straight line. That measures 80, which means this one has to be 100 because that straight line measures 180. And then we do 2 times 100, which would be 200. All right, next property. Angles inside the circle where 2 chords intersect. So we have this chord DC and this chord AB. If we add those together and we divide by 2, we get either one of those angles. And it could be either one of them because they're vertical angles and vertical angles are congruent. Or we could do BC plus AD and divide that by 2, and that means you could get either one of those again because they're vertical angles. So let's see if you can find the problem that looks like this one on your question set. And that's this one. And again, so I want you guys to write arc plus arc divided by 2 equals the angle. And you'll notice here that you have one arc, but you don't have the other, but you do have the angle. So you're just going to plug them into the formula, arc 165 plus, I don't know what. You could put your X there if you want, a question mark, divided by 2 equals 110. Remember how we get rid of a 2 that's in the denominator. I'll talk you through that on another video. Okay, this property. Angles outside the circle. So when we are dealing with angles outside the circle, we're going to do outside arc minus inside arc divided by 2 equals this angle. Again, we got 2 tangents over here. Outside arc minus inside arc divided by 2 equals that angle. And here we have 2 secants. Outside arc minus inside arc divided by 2 equals that angle. So the process for all 3 of these problems is the same, outside arc minus inside arc divided by 2. So let's see again if you can find these problems in your problems set. So this was 12, 14, and 17. 12 is 2 tangents. 14 is a tangent and a secant. And 17 is 2 secants. Outside arc minus inside arc. Outside arc minus inside arc. Outside arc minus inside arc divided by 2 equals the angle. So now we're going to talk about how to convert from degrees to radians. So we got a problem here, 55 degrees. What I tell my students is just divide that number by 180, and on your calculator, turn it into a fraction, and then put pi on top. So that's how we change from degrees to radians. Now let's talk about how we go from radians to degrees. So if we have 3 pi over 2, I just tell my students to substitute 180 for pi. So 3 times 180 divided by 2 is 270 degrees.